Alright guys, welcome to Unit 6 Quiz 1 Study Guide. Let's go ahead and get started here. Number 1, we want to estimate this integral value using a right-hand sum of 6 subintervals. Alright, so since it's a right-hand sum, we're going to start from this dot here on the right side, and we're going to draw a horizontal bar to the left, and we're going to keep going with that pattern. And that'll stop us there. All right, after that, we're going to go ahead and drop a line straight down to the x-axis. In the process, we're going to be creating some rectangles here. And all this is meant to estimate the area under the curve here. We've got various rectangles that we want to find the area of. And that should give me a rough estimate of the area under the curve. So each one of these rectangles has a base of 1. So base times height will basically be 1 times whatever the height is. So it's just going to be the height. So in this case, this is 9. This one's 11. This one's 9, 6, 5, and 9 again. And we'll go ahead and add all that up. And for that, I'm getting approximately 49. Okay, I'm going to repeat this same process, just now we're going to do left-handed intervals. So starting from the left side, we're going to draw some horizontal lines from each dot. I'm going to not draw one here because that's going to go past our curve, so we don't include the last one there. Just go ahead and drop down some lines here to create our rectangles once again. And then find all those areas once again. And for that one, I'm getting 40. All right, let's go ahead and move along here to number 3. All right, so for number 3 here, we are going from -3 to +3. We're going to be using a midpoint sum of 3 subintervals. Okay, so if I'm going from 3 to -3 and I want to break that up into 3 parts, we're going to take the last number, subtract from it the first number, and then we're going to divide by 3. So that gives me 6/3, which is 2. So I'm going to be going by 2s. So from here to here, to here, to here. Okay, so I'm going by 2s. And the reason for that is because whenever you do a midpoint sum, you're going to find the middle point. So the middle here is -2, and the y value for that is right there. And I'm going to be drawing my horizontal bar there and dropping down the verticals like so. Okay, let's repeat that for the next interval. So from -1 to +1, the middle is 0, and the y value that goes with that is here. So I'm going to draw my horizontal bar there, and then I'm going to drop down a line there. And then for the next one, between this interval, the middle number is 2. The y value that goes with that is here, and so I'll be drawing my bar there. And so we'll calculate the areas here. So for my first rectangle over there on the left side, I've got a base of 2 and a height of 9. Therefore, this rectangle has an area of 18 because 2 times 9 is 18. This next rectangle is identical to it, so it also has an area of 18. This last one here has a base of 2 and a height of 5, so 2 times 5 is 10. And adding together these areas will give me my estimation of this integral here. So 18 plus 18 plus 10 is 46. All right, 4. All right, and the last one we'll do here is same thing, but we're going to estimate the area using a trapezoidal sum. For that, basically we're going to just draw a vertical line straight down from each dot, and then connect each dot with a straight line, which gives us a series of trapezoids of which we need to find the area. Now in this case, one of these is actually a triangle. This one on the far right, or sorry, far left here is a triangle. The base is 1, the height is 9, half of that is 4.5, so that's how you find the area of a triangle, 1/2 base times height. For trapezoids, you add each of the parallel sides together, known as the bases. So that's going to be 9 plus 11. And then you multiply that by half of the bottom line here, which is the height, which is 1. So half of 1 is 1/2. And so we end up with 10, basically. Okay, we're just going to keep doing that for each of these other trapezoids. And putting all these values together, we would end up with 45.5 approximately. All right, let's go ahead and move on here. Number 5. Using the graph of g of x below, would a right-handed sum give an overestimate or an underestimate of this function? So you would want to look at your 6.1 notes. It kind of explains this. But whenever you have an increasing function, in other words, it's moving in an upwards direction, and you have a right-handed sum, those are the two criteria you look at, what that ends up giving you is an overestimate. Okay, so the way we would word it is as follows. And there you go. So that's how you'd write that one out. All right, let's go ahead and move on. And before I move on, actually, you can memorize the chart, but you can also just understand the process. I mean, if you have this graph here and just sketch a rectangle, you'll see that it's above the curve, so that would be an overestimate. Sometimes it's a little more complicated than that, especially if it's underneath the x-axis, but you can check your work that way. Let's go ahead and move on to the next part here. Use the table below for numbers 6 through 9. All right, so it says estimate the integral of h of x from -3 to 3 using a right-handed Riemann sum of 6 intervals. So if we're doing a right-handed sum, we're going to be ignoring this leftmost value. We're going to be finding each of these values, which will represent the bases of our rectangles. In this case, they're all 1s. And then these numbers here all represent our heights of our right-handed rectangles. And you just do base times height all the way across. And then you add all these values up. And I get 19 for that one. So that would be the answer to number 6, 19. All right, let's go ahead and do the same thing here now. For number 7, we're doing a left-handed sum. The only difference when you're doing left-handed sum is you're going to leave out the last value on the right side. Now, as we said, all the bases were 1. And these now will represent our heights. So 1 times 5 is 5, 1 times 3 is 3, and so on. So basically all my heights are just going to be these numbers here now. I'm sorry, not my heights, my areas. And then adding all of those up, we're going to end up with 8, 10, 14, 20. So my left-handed sum is 20. All right. Let's go ahead and estimate our midpoint Riemann sum of 3 subintervals. Since we're doing 3 subintervals, you might want to take your last x value and subtract from it your first x value and divide by how many intervals you want. And so that's 6 over 3, which is 2. And that tells you how wide your bases need to be. So in other words, I'm going from -3 to -1 to get a base of 2. So that just basically means we're skipping 1 every time, and that gives me 3 rectangles. Okay? And when you're doing a midpoint sum, for each rectangle, you're going to go with the middle number to represent the height. So that's a height, that's a height, and that's a height. And you just do 2 times 3, 2 times 0, and 2 times 6. Going to add these up. Got your answer. Okay, let's go ahead and take a look at one more problem here. Let's go ahead and do another estimate of the area under the curve, but this time with a trapezoidal sum. So with trapezoids, this distance now is going to represent the heights of the trapezoids. And each pair represents a pair of bases. So the formula for a trapezoid is going to be the height, which is 1 over 2, times the sum of the bases, 5 plus 3. And so that's half of 8, which is 4. So my first trapezoid is going to have an area of 4. Then we repeat with the next trapezoid. So that would be this one. Here's my height. Here's my bases. So 1/2 of 3 plus 2 is 2.5. And we'll just go ahead and keep continuing that process there. My next one. Height is 1. Bases are 2 and 0. That one's 1. Next pair. Height is 1. Bases are 0 and 4. Next pair. Height is 1. Bases are 4 and 6. And finally, height is 1. Bases are 4 and 6. Same thing as the other one. 5. Forgot to write down the last 5 there too. So we have these 6 rectangles. Did I just say rectangles? I think I meant to say trapezoids. Anyway, trapezoids is the answer. And then we're going to go and add all these up and see what we get. So 5 plus 5 is 10, plus 2 is 12, 13, plus 4 is 17, plus 2.5 is 19.5. So there would be our final answer there for number 9. So that's how you can find right, left, midpoint, and trapezoidal sum to estimate areas under curves. All right, let's go ahead and move on to our next question here. Right. So whenever you are asked to do this stuff again, but this time with just an equation, basically you need to create your own table. So the first step you need to do is you need to take your intervals, 6 and -2. You need to find out what the distance between them is, and you need to divide that distance by however many subintervals you want. And that basically ends up being, for me, just 8 over 8, which is 1. So I'm going to be increasing by 1 each time I'm on my interval. So starting with -2, we're going to increase by 1 until we get to our last value, which is 6. And so that's my X row on the top there. The next thing I want to do is I want to create the Y row. And you get your Y values by plugging these numbers into your equation here. So if I were to plug in -2, I would get 4 plus 6 plus 4, which is 14. And you would continue plugging each number into the equation to get all of your new Y values. All right. After you have created your table, it becomes just like the last problem. I'll go ahead and go through it again here, but you don't have to watch this again if you already know how to do what we did up here on 6 through 9, because at this point it would just be repetitive. But just in case, you might want to watch, especially for the midpoint one, but we'll see. Here we go, right-handed sum. So that means we're going to use all the numbers on the right except for this last number here. And all of my bases here are going to be 1s, so and these are my heights. So if I multiply each base by each height, basically 1 times 8 is just going to give me 8 for the area, and then 4, then 2, then 2, and so on. So all these are the areas of the rectangles that I need to add up. And if I add all those up, I would get 64. Let's go ahead and do the next one. Since this one is a left-handed sum, we're going to include all these numbers on the left, and we're going to leave out this last number here on the right. Once again, all of my my bases on the top here are all 1s. And these numbers here represent my heights. And to find the areas, we just do base times height. Since all of these are 1s, each height basically represents the area also. So we're just going to be adding all of these up here. And as a result, we would end up with 56. All right, let's go ahead and move on to the next one. And once again, you'll notice that when it comes to the midpoint sums, the number of subintervals is always going to have to be different than these ones, because you need to use only the middle numbers. So you got to kind of create groups of 2, so to speak. So to find, if you want to break this up into 4 subintervals, you take your last x value and you subtract from it your first x value, and you divide by the number of subintervals that you want. So that's 8 over 4, which is 2. So I want to be going by 2s here. So starting off at the first number there of -2, if I add 2 to that, I get to 0, and then 2, and then 4, and then 6, and that gives me 4 subintervals. And each one of these represent the base of my rectangle. So now the bases are actually something other than 1. They're actually 2 now, right? And since we're doing midpoint sums, the distance from the first to the last, that represents my first rectangle, and the middle number represents the height of that rectangle. So my height is 8, and I really don't care about the 14 or the 4. So we need to do 2 times 8, which is 16. Okay, so you're going to go ahead and keep that pattern up there. So this will be the height of the first rectangle, this will be the height of the second one, this will be the third one, and this will be the fourth one. And so base times height here gives me 16. Base times height here gives me 4. Base times height here gives me 8. And base times height here gives me 28. And then we're just going to add all 4 of these up to get a total of 56. All right. Last one for this set is the trapezoidal sum here. So once again, these numbers up here are going to represent, for the trapezoid, the height of the trapezoid. So these are all 1s. And then these numbers in pairs on the bottom here represent the bases. So the way that you do trapezoidal sums is you take the height, you cut that in half, and you multiply that times the sum of the bases. So 14 plus 8 is 22, multiplied by a half is going to be 11. And we're just going to keep up that process. So my next one here, we're going to take my height, we're going to divide it by 2. We're going to add the next pair of bases, that's 12. 12 times a half is 6. take your next height, divide it by 2. Take your next pair of bases, 4 and 6, add those together and multiply by a half. 4 plus 2 is 6, multiplied by a half is 3. Next height is 1, so divide that by 2. My next pair of bases are 2 and 2. Add those up, which is 4. Multiply it by half the base, half the height, which is 2. And so on. And once you got all your trapezoids figured out, you're just going to add all of these 8 numbers together, and that will give you the area of the under the curve, or the estimate of this integral by use of a trapezoidal sum. And if I'm doing my adding right, I get 60. All right. So now, mind you, most of the work here on 10 through 13 was really just a repeat of what we did on 6 through 9. The real trick here is turning the equation into a table. After that, it's pretty much the same thing as the table questions, right? All right, so let's go ahead and transition now into our next set. I'm giving you the values of some various integrals here. Notice that we've got 2 different functions we're integrating. There's the r function, there's 2 of them here, and there's the k function. Notice their limits are different as well. This one goes from -3 to 0, this one goes from 0 to 4, and this one goes from -3 to 0, and this one goes from -3 to 8. So let's go ahead and see what we can figure out here. Now, anytime you have a bunch of things being added together inside of an integral, we can use one of our integral properties to split it up into separate integrals. Now, how much work you want to show here is entirely up to you. This is going to be a multiple choice exam, so if you can do this stuff in your head, that's fine. Okay. Now, this value here from -3 to 0 of k of x is given to us. They tell us here that it's 5, so that's pretty straightforward. This value here of -3 to 0 of r of x, that's also given to us right up here, and telling us that that is 10. This one is not given, but we have a property for that. Anytime you're integrating a constant value, you're going to take this number here, and you're going to multiply it by the difference of the top number and the bottom number. And so that's 8. And so we have 5 plus 10 plus 8, which is going to be 23, would be the final answer for number 14. Okay. Let's go ahead and move on here to number 15. So we're going from -3 to 4 for k of x. Now, I don't have an integral that goes from -3 to 4. I've got one that goes from -3 to 0, and then I have one that goes from 0 to 4. But I don't have anything that goes from -3 to 4. But we have a property that will help us with that. Anytime one integral, like this one, leaves off at a number where another integral starts at, then you could put those integrals together. So what that means is if I have -3 to 0 for k, if I add that to the integral of 0 to 4, that is going to give me the same thing as if we were just going all the way from -3 to 4. So in other words, these guys are joined here, and by combining these, I end up with that, the thing I'm looking for. So this is what I'm looking for, this is what I have, and if I put those together, I get what I'm looking for. So from 0 to 3 is 5, and then from 0 to 4 is -3. And so the final answer here will be 2. So the answer, number 15, is 2. and move on to the next one here. Number 16. We're looking for the value of 0 to 8 for the function r. And once again, we don't have that. This one goes from -3 to 0, and this one goes from -3 to 8. So let's think of that on a number line. I've got -3, I've got 0, and I've got 8. Okay? Well, this one goes all the way from -3 all the way up to 8. And that integral gives me a value of 4, it looks like, right? This integral only goes from -3 to 0, though. And that one gives me 10. Now, this obviously is not drawn to scale, but it could help us understand the process a little bit, okay? So how do we figure this out? This piece plus this piece should give me this value, okay? So how do we do that? We'll call that x. So 10 plus x should equal 4. Oops. And we end up with a negative number there as a result. Okay. Now another way to think about this problem is as follows. You could say that the integral from -3 to 0 of the r function plus, you got to pick up where that one left off at, 0 to 8, which is the one I'm looking for, by the way, should be equal to the integral from -3 to 8. Because once again, if you have one integral where it leaves off at where the other one picks up, you should be able to combine those together where you get a total integral where this one starts and this one ends, which is what that is. Okay, but it's going to be the same answer. From -3 to 0 is 5. I'm sorry, that's actually for the k function. You've got to be careful what function we're using. From -3 to 0 is 10. This is the part I don't know. And this is 4. Same equation, but either way you want to do it, you go ahead and get -6 as a result. Go ahead. All right, so for number 17 here, we have noticed that, first of all, these numbers are backwards. We have the bigger number on bottom. It's supposed to be the smaller numbers on the bottom. So we're going to reverse those, and we have a property that says we're allowed to do that so long as we put a negative in the front. Okay, I have another property that says I'm allowed to take any constant multiple out of the integral. So I'll put that 3 in the front with the negative now. And now I'm looking for the integral of k of x with respect to x on the interval from 0 to 4. Well, that would be right here, and they tell me that that is -3. So I've got a -3 in the front, but that integral is also equal to -3, and therefore the final answer would be 9. Let's go ahead and take a look at another set here. So let's use the graph of w of x below to evaluate each integral below. So we've got 4 different expressions that we want to find the integral of. And what's helpful here is remembering that these represent area, right? It could be helpful for us to go through and find the area of all these different pieces. So I've got a little triangle here. We have a trapezoid here. And we've got a triangle here. So what I want to do is I want to find the area of each one of these little pieces before I begin. All right, so this little triangle, base times height divided in 2, is going to be 0.5. But notice it's below the x-axis, so we have to remember to make that a negative. This trapezoid here, base plus base, that's going to be 1, 2, 3, 4, 5 is one base, and top base is 1. So 5 plus 1 is 6, times the height, which is 12, cut in half is 6. So that trapezoid there is 6. And the area of this triangle, base times height, That looks like 1, 2, 3, 4, 5 times 2 is 10. Cut in half is 5. And we're going to make it negative because it's under the x-axis. It might be possible that we have to cut this trapezoid up into pieces, but we'll see as we go along. But basically, you're going to have to go through and find some area as you go. So let's go ahead and see what we got. So the first question is asking us to find the integral of w of x from 0 to 11. And what that means is they want to find the area under the curve, or between the curve and the x-axis from 0 to 11. In other words, the whole thing. So that would be like adding all the pieces together. So we have negative 0.5 plus 6 minus 5, which is going to be 1 to 0.5. Final answer. Okay. Number 19, we're going to start throwing in some properties, though. Notice that we have the bigger number on the bottom and the top. So the first thing I want to do is we want to reverse that. I'm going to put the 0 on the bottom, 6 on the top. And to do that, we need to throw a negative in the front. Another property I'm going to apply here is I'm going to separate these integrals. I'm going to do an integral of w. And then I'm going to do another integral of 3 separately. Now this is going to become plus. Why does that become plus? Well, it was a minus, right? So when I take this negative integral and apply it here, the two negatives cancel out to become a plus. Okay, so let's go ahead and see what we get here. So first of all, I want to find the area of w of x from 0 to 6. That's from here all up to here. So that was the trapezoid, which we said was 6, and this little triangle, which is negative 0.5. So this piece here will be negative, and then we're going to put in here the numbers that they give us. Trapezoid and triangle. And then plus. And we have a property for this. Anytime you're integrating a constant, you're going to take this number and multiply it by the difference of the top number and the bottom number. So let's simplify it. This comes out to be 5.5. This comes out to be 18. And so the final answer here will be 23.5. Right? Let's go ahead and move on to number 20. Now with number 20, basically it's going to give us the same thing we had for number 18. Notice they're almost identical, but the difference is we have this absolute value. You guys might remember on number 18 we had negative 0.5 plus 6 minus 5, right? Well, the difference is that when you take the absolute value, all parts become positive. So now it's a positive 0.5, a positive 6, and a positive 5. And so the end result here will be 11.5. Okay. Number 21, the last one for this set. This is a U sub problem. We don't like that being in there, so we're going to treat this like a U sub. My U is 2x plus 1. We're going to find the derivative of U with respect to x, which is 2. And then we want to get the dx by itself, which will look like this. After we do that, we're ready for our U substitution. We're going to have w, and in the parentheses, we're going to replace the 2x plus 1 with u. We're going to replace the dx with du over 2. And then we also need to change our limits, because these are x values, and we want to change these to u values, and we get those by simply plugging them in to this equation up here for x. So, taking the 5, plugging in here, I get 2 times 5 plus 1 is 11. And taking the 0 and plugging it in, 2 times 0 plus 1 is 1. All right, we're almost there. So now that I've got that, I've got w of u, du from 1 to 11. And I'm going to take this 2 on the bottom here. I'm just going to move it out here to the front like so. All right, so now that we've got that, we're ready to go ahead and just find the problem. So after we do our U sub, it's just like the other ones we've been doing so far. So we have 1/2, and we're going to find the integral of w from 1 to 11. And that's basically just the area under the curve. So that's the trapezoid here plus the triangle, which would be, the trapezoid we said was 6, and the triangle we said was -5. So this equals 1 times 1/2 is equal to 1/2 is the final answer for that one. Okay. There you guys have it. So that's that section. Then we got one more set down here. These are the ones where you have to turn the equation into a picture, and then you're going to go ahead and find the area based on geometry. So when we looked at these, we have a little formula here. Okay, so the R represents your radius. So whatever number's right here, you have to take the square root of it, and that'll tell you your radius. The center of our circle will be this number and this number. Got to remember, though, that the h will always be opposite sign from what it is in the equation. So up here, like I have a -h, so here it's positive. That's not true for the k. The k is what it is. So if it's positive, it's positive. If it's negative, it's negative. The other thing we got to remember is that if you have a positive square root, then that means you're looking at the top half of the circle. And if you've got a negative square root, that means you're looking at the bottom half of the circle. Anytime you're missing either the h or the k, they are zeros. So keep that in mind as well. So let's go ahead and begin here. For our first one, taking the square root of this number, I will find r, which is 2. Next, to find my center, I'll label that C. We take our h value, which is not present, so that means it's 0, and our k value, which is 1. I think it's 1. Yeah, there we go. And so my center is 0, 1. And then notice there's not a sign in the front, so that means it's positive, and that means we're looking at the top half of a circle. So I'm ready to graph this. I'm going to plot my center at 0, 1. And then I'm going to use my radius from my center to go right 2, left 2, and up 2. So from my center, we're going to go right 2, left 2, and up 2. Then we should be able to connect our dots with a half circle. So now we're ready to go ahead and actually find what they're asking us to do. They want us to evaluate this. What is the integral from 0 to 2? In other words, we're going from x equals 0 up to x equals 2. So I only need to start from here and work my way over to here. So what we have then is I've got a quarter circle on the top and a rectangle on the bottom. The rectangle on the bottom has an area of 2. The quarter circle can be found by doing pi times the radius squared divided by 4, which is just pi. So the answer to this equation will be pi plus 4. I'm sorry, pi plus 2. There you go. Let's go ahead and take a look at number 23. In this case, my radius is 3, the square root of 9. My center is -2 for the h value and +5 for the k value. And since we have a negative in the front, we are looking at a lower half of the circle. And I am therefore ready to graph now. So my center is left 2, up 5. And using my radius, I want to go right 3, left 3, and down 3 this time, because we want the lower half of the circle. And that's what that looks like. Now, my goal here is to find the area under the curve, right? Not a very nice looking picture, but there it is. So we have a rectangle, and then we've got these two little ramps that we've talked about before. So for this rectangle down here, the base is 6, the height is 2, so that's going to be an area of 12. And then for my ramps here, the way that we do that is we do the area of the ramp is equal to the area of a square minus a corresponding quarter circle. The length of the square and the radius of the quarter circle are whatever your radius is here, so that's 3. So the square is 9, and the quarter circle would be pi r squared, which is 9 over 4. So we have 9 minus 9 pi over 4 for each of these ramps here. And we have 2 of them. So each one is 9 minus 9 pi over 4. Oops, don't like how I wrote that. There we go. Now they want us to calculate the area of this thing from -5 up to 1. So that's from here all the way up to here. So they want the whole thing. So all these pieces added together. So my first ramp is 9 minus 9 pi over 4. The rectangle on the bottom is 12. And the other ramp is also 9 minus 9 pi over 4. And so we just need to add all these together. So the way we'll do that is we'll add together all the whole numbers. 12 and 9 makes a total of 30. And then negative 9 pi over 4 plus negative 9 pi over 4 makes negative 18 pi over 4. And that fraction can be reduced. So we end up with negative 9 pi over 2. And that would be our final answer right there. So that's for number 23. Let's go ahead and take a look at number 24, our last problem. On this one, my radius is the square root of 1, which is 1. The center, there's no h and there's no k, so that means the center is 0, 0. And we are looking at another negative situation here. And when that happens, we're looking at a lower half of the circle. So since my radius is 1, we're going to go right 1, left 1, down 1 from the center. Connecting those, we get a semicircle down there. Now we're going from -1 to 0, so that's from here to here for this particular integral. So I'm only looking at a quarter circle on the bottom. And as you guys may know, is the area of a quarter circle is pi r squared over 4. And so we end up with pi over 4, but we got to remember that that is underneath the x-axis, so it's negative pi over 4. Okay, so final answer there, number 24, is negative pi over 4. And that'll do it. So hopefully that was helpful. And obviously you're not going to have this many questions on your quiz, but when you get there, we'll see how many you guys can get done in the class time we have, but it's not going to be that many. Anyway, hopefully that was helpful, and we'll see you guys in class for your quiz. Have a good rest of your day.